Our next speaker is a data scientist at ReturnPath and holds a degree in mathematics from the University of Colorado, Denver. Please join me in welcoming Sasha Mushovic.
Thank you all. Thanks for coming. I'm excited to talk to you guys today. I'll be talking about data product life cycles and how to empower data science teams to own building end-to-end data product solutions. I will talk a little bit about the technology and the packages that are mentioned in my outline, but the presentation has kind of evolved to focus a lot more on the process. So hopefully we'll get some good content out of that and have some good takeaways. So I'll start with telling you guys a little bit about ReturnPath. We're an email intelligence company. We have a lot of vast data resources that get us great email data, which gives us insight that allows us to help our customers optimize their email marketing programs to solve problems like sending the right content to the right people at the right time to optimize their ROI from their email marketing program. A little bit about data scientists at ReturnPath. We identify ourselves as people who continually innovate on better solutions to persistent, important client problems. So that doesn't say anything about ML or AI or how we solve those problems. The emphasis is on understanding and solving them. So the skills that are involved in that, to be a full stack data scientist at ReturnPath, you obviously need to have a solid understanding of mathematics and statistics to be able to implement these algorithms and solve the problems. But you also need the data communication, which goes beyond being able to communicate your results to your stakeholders. It's also domain expertise and truly understanding the client, and that goes back to being able to identify their persistent problems, and how they might go about solving them will help you identify how to solve the problem. Then there's also some software engineering skills required as well, because you need to be able to deploy your models, that can be kind of a blocker sometimes, but we have data engineers that help us with that. We also have data analysts on our team, but a data scientist should be very familiar with all phases of the life cycle and have all of these skills. So I'd like to talk a bit about the data product life cycle. This is one representation. There's no perfect graph for it, but I like how this one iterates back on all the previous steps, and I think it has most of the important phases listed here. So I'd like to just take a moment and ask you guys, what do you think is the most important and or most time-consuming phase of this life cycle? That one can be really big. That can be a pain, especially if you're doing supervised learning and you need to label your data sets. That one can take a long time. But I would also argue that discovery is a big one too, in importance and how long it takes. Being able to really, truly understand that client problem and dive deep to be able to build something that won't only look cool and help the product, but something that will actually solve their problems and drive retention. Operationalizing is also a big one too. That can take quite a while. But I'll come back to the product life cycle, and I'll actually illustrate all the steps in this life cycle by going through the story of email text classification at ReturnPath, the project that I worked on. But first I'll show you a little bit about our data so you have some context. In my opinion, our most interesting data source is the email panel that we have. So we have millions of people who have downloaded apps and have opted into anonymously providing their information about how they're interacting with their email inbox. So we get some really great metrics around what they're doing. First of all, did it even land in the inbox or did it go to spam? Because that affects whether they were even able to see it and read it and click and convert. We can also see if they read it, if they deleted it. If they moved it, that might be a good sign that they saved it for later in a special folder. TIS stands for this is spam, so did they complain about your message? Or this is not spam, did they dig it out of the junk box because they like you so much? So it's a really rich data set, and you can roll it up by tons of things. So you can group by ISP to see how someone's doing at Gmail versus Hotmail. You can group by sender domain to compare one of your clients to their competitors. We can also group by IP address. We can get down to the subscriber level. And we can also do campaign level with associated subject lines to see how different campaigns for your client are performing over others. And then we have some really great features that we can join to and get even more content. So sender industry, maybe you want to show someone how they're doing benchmarked against their entire industry. We also have countries for sender and subscriber, so you can do regional analysis. And our data science team has spent a lot of time on the subscriber features. So we have profiles for subscribers for how they're interacting with their inbox overall. And then we have specific subscriber domain pair engagement scores. But we didn't have a content-based feature going down to the campaign or the subject level. What if you could tell what kind of campaign it was and be able to roll things up by, is this part of a welcome series, or is this a loyalty program or a win-back campaign? So that could be another great feature to roll up by and provide insight to the client. So that's where the idea of message classification came into play. We have the data. As you saw, we have the subject lines, the campaigns. We even have the entire email body. It's stored somewhere else, and it's a bit harder to get to, but we have it. So that would be a great potential solution. So we spent a lot of time kind of iterating through this design process, not actually designing what the solution would look like in the tool, but thinking about what are the use cases across the entire product, who could consume a feature like this, and what are the data assumptions that we're making. Like I said, we have the email bodies, but I've never seen one. How would we access that? We're assuming a lot of things. And with that comes a lot of cost and risk in undertaking such a large project. So how do we get business buy-in to do so? We ended up pitching a phased approach, which was, like I said, my goal was to build this model that would be versatile enough to be implemented in various different pieces of the product, but I had to identify an immediate business goal in order to get that buy-in. So there was this report that our services team was doing, and it was essentially what I wanted to automate. They were, on a client-by-client basis, they were downloading data from our tools, and then they were manually tagging it by these campaign types and rolling it up and providing insight off of that. And it was taking them 50+ hours to do so. So we were able to identify this phased approach where eventually we would automate the whole thing once we have the model. But in the beginning, we could at least automate the data pull and the roll-up piece on either side of the actual tagging. And we could still facilitate the tagging by clustering campaigns by subject line similarity. So that would automatically reduce the report from 50 hours of time to 20 hours. And then we would collect the tagged, all the tagged data that they were doing, save that off for our training set, build the model, and then come back and replace that manual step with the message classification results. So that was enough to get business buy-in. We had this immediate solution, and it was also this phased approach that we would prove out a lot of assumptions along the way before moving on. So that would mitigate a lot of risk for us. And that phase one was pretty successful. I was able to develop in Qubel. I was able to write a boosted k-means algorithm that rather than finding the optimal k, you can find a contextually appropriate k to find the right amount of clusters for the particular client that you're trying to cluster for. And then I was able to prototype this in Qubel notebooks, and it was this interactive dashboard that the services team was able to come in and test, provide feedback to iterate on, but it wasn't fully prod ready because there were some accessibility issues. We didn't want to onboard the entire team into Qubel at the time, and also some functionality issues because there's still this piece of downloading data to tag and then uploading it back, and we didn't want to bring all those people into S3. So we had to find a way to get this tool into a more stable prod environment. So we ended up deploying an Airflow, which allows you to set up some directed acyclic graphs to manage a series of dependent cron jobs because all these steps depend on each other. You have First, the user submits a request, and then the clustering is done, and then they send that email to the user so that they can tag it, and then they have to come back on this whole other thread, and they have to upload it, and then all of the roll-up will happen, and they'll get that email back, and then that final step is where we are retrieving, for all the messages that they individually tagged, we go and we retrieve the associated body, and we store it for the training set. So that was a pretty successful phase one. Moving on to phase two, actually just to show you how flexible Airflow is, this was a really complex process. I'm not going to go through all the steps, but I just wanted to show you that Airflow can really handle some cool stuff. It's more than just scheduling a job to run at the top of the hour. It can get kicked off by an external signal as well. So that was pretty successful. It was the first time we used Airflow in the company. So now that phase one is done, as we're waiting for that data to roll in for the training set, we move on to phase two, discovery. So what is it that we're going to tag? Before, for different clients, they were tagging different things and getting really customized. But to build one message classification model that would work across the company, we need a standardized set of classes that we're going to use. So what is that standardized set? First, we have to think about the opportunities, about where this is going to be deployed, what the target market is for it, and what they need. So we drafted a proposal. We were able to use the phase one results as a prototype. And then we went out into the field and gathered feedback from clients and did a lot of interviews. We wanted to understand how different industries are segmenting. Does banking look at it the same way as retailers? We paid close attention to terminology. Are they just using different words for the same thing, or is it truly really different? And then we also looked into use cases about what would they do if they had this data. And it was a good sign because they had a lot of ideas. It's obviously something they had thought about before if they had it, and they were able to give us some really good ideas. So then we came back and adjusted all of that feedback and came up with a standardized set of tags that would please as many people as possible. This is what we came up with. We knew what to build, we knew what kind of problems we could solve with it, and we knew it's worth building. And then here's just an example of all the tags we came up with, and the metrics I showed you earlier now rolled up by those tags. So you could easily gain insight out of this. For example, if this client saw that their inbox rate was the lowest for welcome, but they also have a higher read rate for welcome, that could indicate an acquisition problem. So that immediately gives them something that they can go back to and try to improve their program. So after product discovery, there's also the data discovery side. We kind of knew from the beginning that the subject line, even though we were able to cluster it in the first phase, that it wasn't going to be enough context to actually classify an entire campaign. We had to get a hold of the message body, which we knew was out there, but how are we going to access it? A message body could have personal information in it. We have a really great redaction system, but there are still a lot of limitations around getting your hands on that data. And then storage. It's obviously being stored somewhere, but is it in the format that we need it, or are we going to have to build our own data lake and have a huge ETL around it? And then there's processing as well. It's all in HTML format, so how are we going to extract valuable information out of that? So we had to prove out the pipeline. And luckily, another benefit of that phased approach is that we had already done so. With that step in the previous DAG I showed you, that for every message that they manually tagged, we went and retrieved the body and stored it for the training set. So we already have access and storage figured out by now. The only thing we had to focus on was processing, and it was pretty simple to come to the conclusion that, Beautiful Soup from Python was actually a really good solution for that. So now that the discovery's done, and we had been waiting for that training data to roll in, but it wasn't coming in fast enough. We needed a lot more messages, so we had to pull out all the stops and get help from other people across the company to tag, because I can't tag 5,000 messages on my own. Help me out here. It was a bit difficult. It's kind of like pulling teeth. And then you kind of run into this issue of quality versus quantity. The harder you push to get people to help, maybe they won't care as much, and the quality could go down. But the quantity is really important too, so there's that trade-off there. There's also just the the idea of these subjective people, like what if they don't view loyalty programs the same way as other people? So how are you going to get that consistency across your training set? That's part of the balance as well. And then you also want to focus on distribution and make sure that the training set covers lots of different industries so that the model understands banking terminology as well as retailer terminology. And seasonality as well. If it's only been trained Black Friday emails, it's not going to know how to deal with a summer beach type campaign. So this is a really important step that we called out at the beginning. It's one of the most important because the model's only as good as the data you put into it. So now that we have our training set, we put a lot more time into that, we can start modeling. I actually spent the least amount of time here. Part of it was time constraints, and part of it was because we had already proved so much out along the way that I was just ready to go. So I tested a bunch of different models, regression, support vector machines. For decision trees, I looked at both random forest versus gradient boosting. This is all in scikit-learn, by the way. But then I pulled in neural nets as well with Keras. And for evaluation, it was kind of difficult to figure out how well these models were performing because we have 10 classes, and they're all extremely imbalanced. There's not that many welcome messages, but there's a ton of loyalty messages. So we had to come up with our own scorers to be able to weight the different classes in different ways. And then even with that, we found that different models were performing better in different categories, which kind of makes sense that some could pick up on these subtle cues that the win-back campaigns were throwing out versus something larger like the whole promotional category. So we just ended up ensembling the best ones. And I looked at a couple ways of doing that, but voting was simple and sufficient, and there wasn't a lot of benefit from digging too much deeper into that. So came up with a pretty fast and simple model. I just want to talk a little bit about the tuning tools I used. So you have grid search and random search. Those are like these really great tools that you have in scikit-learn. And when you start moving into Spark and scaling up, Spark has their own version of grid search because it's natively parallel, so it makes sense that you would want to distribute all of that out across your cluster. Same doesn't exist for random search because it doesn't work the same way. There's also hyperopt, which uses Bayesian optimization to approach an optimal solution. It's not as easily distributed, but it approaches the solution really quickly. So I ended up, in further iterations, I ended up moving away from grid search and just stuck with hyperopt towards the end. But either way, Qubel was a really great tool for this because if you're testing 10 different models and 3 different types of ensembling, and each model has so many hyperparameters, it was really nice to just be in the Qubel platform and all of the auto-scaling was taken care of for me. So once I figured out that you had to use Spark's grid search and not Python's, that was really easy. So we have the model tuned and built, and now is when this use case emerged. So we had built it not knowing exactly where it would go, but knowing that it would be really valuable. So now product, they kind of had the bug in their ear that this feature was coming. Now that it's ready, they wanted to build a new tool off of it. So in email marketing, a lot of the creative part of it is figuring out how to make these nice campaigns that'll perform well out in the wild. So this is a browse campaigns feature where you can go out and see real campaigns. You could focus on your competitors, or you could just filter by industry. There's a filter there for that. And then you can also filter by campaign type. So let's say an email marketer wants to write a really good birthday message. They can come in here and filter for that, and all of these results are sorted by how they performed out in the wild. So you can see a really great birthday message versus a really poor one. So once product was ready to do that, we were really easily able to get a semi-production environment going. I had developed in notebooks, so all I had to do was schedule the notebook to run once a day and consume in batch, and we were immediately able to use those results in product. Now, we wanted it to be more stable, more prod-worthy, so we moved it into Airflow, which I showed you guys a little earlier. This one was a lot simpler because there aren't so many steps. It's just one batch job that runs once a day. But Airflow allowed us to deploy easier, and it has, since it's more easily connectable to GitHub, it has a lot more version control. So that was a really nice solution. In the future, we'd like to, because it's all in batch right now, we'd like to open the model up to be able to process in streaming, because our data pipeline team uses Kafka. So what if they could consume the model much further upstream? So we're thinking about turning it into an API and deploying in Docker and Kubernetes. We're also looking at SageMaker, but we're trying to figure that out because we really want this model to be flexible enough to process in batch or streaming and allow this like independent ownership between analytics owning the model and product owning how they can consume it. So I wanted to show you the Airflow Dag we made for message classification. First, I just want to remind you how complicated the first one was, and you can see how simple the second one was. As I said, it's just this once-a-day batch job. It's pretty big. It's processing about 7 million messages a day in 10 minutes. That's pretty cool. And all the results get stored into S3, and from there, the product can pull from it however they want. So you have the Browse Campaigns product that I showed you the screenshot of. We also have the tool from phase 1 that I had promised to go back and replace those results and automate that final step. And then we also have Hive tables and Kubel and dashboards that enable analysts to explore this new feature and build new things off of it. So that was a pretty successful illustration of independent ownership, and also of a data science team building an end-to-end solution from discovery all the way through production. I'd like to take some time to reflect a little bit back on the process and on the life cycle and on what it means to be a full-stack data scientist. So self-sufficiency is really important. A data scientist can do all of these things on their own, but look how much time it took me to do discovery and operationalizing. I actually spent very little time on the model building, and total time to market was 8 months. So it's empowering to be able to do everything on your own, but is it efficient? You can see with phase 1 in comparison, we had a lot more support. We were able to pull in product and UX in the discovery phase, data engineering in the data prep and the operationalizing phase, and I was able to spend a lot more time on actually building the model and doing what I'm great at. And time to market was a lot faster. This only took 3 months to crank out. And I think the key difference here was that executive buy-in. With this phase 1, we immediately had that tool that we could tell them that we would reduce the time to produce that report from 50 hours to 20. We put some dollar amounts on the new revenue that would generate, and we were given a product manager who had the power to give us everything we needed, pull in UX, front-end engineering on an ad hoc basis whenever we needed it. As opposed to in phase 2, we knew that the feature would be able to be used in a lot of different products, but the actual product use case didn't come up until after the model was built. So we didn't have, the business supported us. They said that would be cool, you should really do it, but we didn't have that full out product buy-in. We didn't have a product manager, and it took a lot longer. How do we take that information, and how do we help businesses grow excellent data science teams? I think it's a balance between the self-sufficiency and the specialization. You want your data scientists to be able to do all of these things, because even with specialization, they're still going to have to own these phases and collaborate with people. So this is a model we're exploring for how to approach data science projects in the future and how to have more cross-functional collaboration. I think it's really important on the discovery side to have product and UX and even service experts too, because they're connected day to day with our clients and they know what those pain points are. So that can help cut the discovery phase down quite a bit if you have that support and expertise that you're drawing in, but the data scientists should still lead it because they're the one building the solution. And then for data prep, obviously it's really helpful to be able to have some engineering resources if it's difficult to access your data, and analytics resources as well if you need some QC or even just, our analysts are data experts. They know everything that's out there, and maybe you forgot that one other table exists. The data scientists would still own all of the model building, but they'd be able to spend a lot more time on it because of the help they're getting in other phases. And for deployment, we're kind of thinking that the data engineer would actually be the primary person on it, they would own it, but the data scientist would still have to be really heavily involved because you don't want to do a straight up handoff. A lot of things can get lost in the way. If you deploy the model, you need to know if it's working or not, and you need to know what you can and can't change when you're scaling and deploying. So that should be a really close relationship in that phase. And then monitoring as well. Sometimes you run into the problem of the person who built it owns it for the rest of their life, and if it breaks, that's the person you go to. But if you set up proper monitoring, we actually have QC analysts in our department, so they could actually be monitoring it if the data scientist works with the data engineer to figure out what are the criteria for if the model's still working or not, and then how to get the alerting set up in Scalar, Prometheus, or whatever you're using. So that's kind of what we're working with and how we're trying to improve this process. I'd be really interested to know from you guys what your dream teams are and what this process could look like and how to reduce friction from innovation to market for data science teams. So that's all I have. I'll take questions, and I'd love to hear from you guys on what your dream team is.
I have a couple questions. I have many questions, actually, but let's start backward. Can you go back to that slide? So that chain, no, next one. This chain is data scientists must have the skills to be there, or you see it as data scientist plus product guy plus UX, they have to work together? Because now it's like in production, since you're asking our opinion too, actually data scientist is same as data engineer and analyst. And like I'm talking about Circle 2. And for Circle 1, it's data scientist, it's same as product guy and UX. So that kind of happens and a lot.
Yeah, I think it is important for the data scientist to also be a product person and a UX designer and a data engineer and an analyst. That's kind of where you get into the idea of full stack. And I think it's important for data scientists to be able to do all of that. But it just takes a lot longer. And then the specialization part, the model building, can be hindered by that.
So how do you manage that, like teams, like, okay, data scientists works with product and UX guys, and next step, do you have like any flow? Because it's like 3 people, they may have their different visions. Is there like a flow? Okay, let's split it. You do algorithm, you tell him how to do algorithm, I mean, in terms of like how to apply it. So can you a little bit tell more about that from your perspective and experience?
Yeah, I think that's why I kind of did a triangle here for my dream team. Yeah. I think if you have a product manager and a data engineer with whom you're interacting on a regular basis, by the time you get to those phases, whether it's deployment and you're starting to work more closely with the engineer, they're already up to speed on the project and they already understand everything that you've done up to that point. And same thing with product. They're much more involved in the beginning with discovery, but they also need to understand, at least in my company, the product managers have a lot of power over bringing in ad hoc resources. Like, that's why I put these other things in clouds, is that they don't have to be there the whole time, but if they're available to pull in when you need them, like let's just do one sprint where we pull UX in, the product manager can help you do that.
Okay. May I ask about models and stuff?
Mm-hmm.
Okay, you had that K-means, then decisions trees, logistics. So I thought initially the problem was to build clusters. How, like, maybe I didn't get like 100%. How did you manage it? Like, so how did you move from clustering to regression? Or you have different approach where you do clustering then? So can you explain a little bit more?
Yeah. Most of the clustering was just, that was the solution for phase 1, okay. Which that provided us with the training set, but it didn't really do anything for the model in particular. So when I started modeling, I explored clustering again to see if there was some way that we could have clusters and then assign labels to them that would represent all the classes. So it was kind of a different approach using a similar method, But that one didn't really work. The models we ended up using were regression, gradient boosting, and support vector machine.
Could you explain more about the custom scores to evaluate your model?
Yeah, so it was a little complicated because the way that we had the classes, let me show you that list of tags, it was almost hierarchical because a lot of these things like loyalty campaigns and birthday campaigns, they kind of fall under promotional. Or they could be considered promotional, or they have a big aspect of that. So we wanted, anything that was remotely birthday related, we wanted to pull into that category and keep it out of promotional. So the custom scoring we did was minimizing the false positives on birthday while minimizing the false negatives on promotional, if I remember that correctly. It was like 6 months ago. Does that help a bit? Yeah, what we did was, I looked at the F1 score. So yeah, that's like combining the recall and the precision. So we were looking for, forgive me if I switch the two, but we had max recall for promotional and max precision for everything else. And then we were making our own custom F1 score out of that.
You guys work entirely on the receiving side, right? So your clients, like you'll have a retail client. They're the same ones sending the emails also, right?
Sometimes. A lot of email marketers work with email service providers to send the mail for them. But they're the ones creating the content. And sometimes if they're big enough, they'll send it themselves.
Right, but even if they're going through through someone else, they're going through a MailChimp or ExactTarget or whoever. When you said you went to your customers to talk to them, don't they already categorize their campaigns when they send them out? Don't they know that's a win-back campaign? Don't they already know that that's a promotional campaign?
Some of them do. You'd be surprised that it's not a more common practice. Also, when they categorize it, if they categorize it, they get their ESP data back, which has delivered, bounces, and it kind of skips the inbox and goes straight to open click conversion. Mm-hmm. And what return path provides, we fill in that missing gap of whether it landed in the inbox or not. And then we have other interesting metrics like moved and TIS and TINs. So we're trying to layer this new valuable information on top. But if we're not integrated with the ESP, we can't see the campaign tagging that they're doing if they are doing it.
Right. So is that something you do though to check your model? Because for the ones who do tag their campaigns, do you see that our tag matches their tag?
I did look into that, but then you kind of get into the too much customization. If they're tagging their own emails, they get super specific, like welcome one, or not even that. Like there are different categories that might be rolled up in promotional. Maybe they have a BOGO and really specific things they're tagging for that we couldn't do if we wanted to have it versatile enough for all of our client base.
So how do you monitor this thing in production to make sure that it's...
It's a great question. We're trying to look into reinforcement learning, but there's this huge issue of how do you get your labeled data sets. So unless we have the support for tagging, we can't really go back and see how the model's doing over time. So we're trying to figure out how to deal with that moving forward. This is the first model we've built that involves tagging. So we're still trying to figure out, with the culture of the analytics department, how can we have this continued tagging going on so that once a quarter we can evaluate and retrain.
All right, well, that's kind of, I may share our experience with that. So we kind of do similar, not similar, like different problem, but the way we deal with that as a data science plus engineering team, we sometimes, for analytic team, you're talking about culture, we build some UIs, and they hire some interns or somebody that just manually tags them, and it's actually sometimes on our side like to make sure their work is easy. So they tag it, save it into database, then data scientists, data analysts, and whoever builds a process and a model, they actually use that data.
Yeah.
So that may be one of the solutions. I don't know how scalable it is, but sometimes it works.
Yeah, that would be a really great. We tried to go down that route. We have a really nice UI for tagging, but we don't have interns for analytics, so we're still trying to figure out who would. I mean, we might try to share that responsibility throughout the analytics department, and maybe everyone could tag 100 per quarter and have that build up.
Also, there is a company, they reached us. What they do, they tag, so they outsource that work. And they have APIs. I forgot name. I can Cord Flower. So
Okay.
what they do, they tag videos and images or whatever like data they use. So basically, it's a hub where you upload your data, and then they outsource it. And like people like from all over the world, like who wants to work on site, they manually tag, and they have statistics like for like how they tag. So they kind of like have some intelligent approach. So that's another way like to deal with that.
Okay,
Yeah.
thanks. How about the dream team? If there's no other questions, does anyone want to tell me how your teams are structured? I'm also playing golf later today, if you want to.
Yeah, so I've been with, I think, 3 different companies, and they kind of follow similar patterns with the triangle you have. But one thing I've seen where the dream team is successful is that people are not bound to their specific roles. So how you mentioned for the data scientists having multiple roles, we've seen that for data engineers also to be able to understand a little bit about modeling work, feature engineering work, and then for product to also have some good understanding about that, where the teams are more successful.
Great, thank you. Can I ask you a follow-up question then? So is that something that you hire specifically for, or is that something that you've fostered within your team?
Yeah. This is more fostered.
Okay.
Yep.
The next step is we want to figure out how to make it streaming. So like I said, we're looking at SageMaker or at building our own API that we would deploy via Docker and Kubernetes. Realistically, it'll probably just be me. But we did, our analytics department is growing because of the big ML AI hype, and business really wants a lot more ML solutions, and we've been able to grow the analytics team and have our own data engineers in-house rather than having to put a request in for resources. So hopefully that'll make things go a lot smoother. I might be able to work with one of them.
All right, we'll go ahead and conclude. Thanks a lot, Sasha.
Thank you.